Yes, in fact, the next one was, now we know that the building and construction industry is energy intensive, right? It's one of the highest emitters of carbon. Have you measured what are the emissions arising out of the process of making those boards, right from sourcing material until the final product? Just to give us like a
In
kind of
this material.
this material, yeah.
So to make cement, they need 1,400 degrees of temperature, and they need to burn coal to be on a continuous basis. That's how cement is made, and they build cement plants on limestone areas and the
Yeah.
entire system. In this, we only collect the plastic. It's logistically moved in a vehicle to a recycler, and the recycler needs to generate 250 degrees of heat. This 250 degrees of heat is again generated by coal, but it is done through thermic fluid. So thermic fluid is an item that holds heat. So it is through that this sheet is made. If I were to quantify energy requirement, I would say it is 1% of making it cement and concrete,
Okay,
right?
that's
As an
interesting.
estimation.
Yeah.
In terms of water consumption, for a 3,500 square feet home, and you will ask any architect or a contractor today, nobody will give you this answer as to how much water you use to build this home. How many liters of water? They do not quantify this. We did in one of the locations to one of the architects, and he was building a 3,500 square feet place. So we separated out the water needed to keep the dust down, where they just spread it on the site, the amount of water they need to mix in the concrete, the amount of water they need to cure, and the total water that accumulated was 130,000 liters of water was used to build a 3,000 square feet home, 3,500 square feet home. In this, we are a completely dry construction, right?
Okay.
Any of the things that we have seen is that we have practically no water apart from what is being used to make the cement board itself. And the cement
So
board is
can
just
yeah.
6 millimeters. And
So can we buy these sheets in the market?
yes,
Just
today you
like
can
we
buy
buy.
these sheets in the market.
Okay.
They're not
Just like
they're
we
not
buy
very
them.
popular. There are a few people in Pune and a few people in Gujarat. Yes, it's possible to buy this material. Um, we make it into a panel like this, but as a
So
sheet itself, it's now available.
yes, I think we missed this point in this video, which is that you're replacing the packaging material is another significant contribution of this technology. So can you just elaborate it in a minute?
Replacing in honeycomb, you're saying?
Yeah, yeah, see, packaging material, yeah. Even for the fridge, you said replacing thermocol packaging and things like that.
So we replicate the honeycomb technology, sandwich it with paper on both sides, and create a super strong material that is now suitable to be used as a replacement to thermocol.
Can you?
This material now has recyclable value, uh, which right now, if typically a home has to get rid of thermocol, they have to pay the guy to get rid of
Mm.
it. Versus this now material coming in goes at a value of 15, $18 from a home today.
You said you have a deal with Godrej.
We package 75,000 refrigerators every month, where we replace this packaging. We do it for multiple companies like Godrej, Whirlpool, and because it's a white good industry, it is now being replicated and being encouraged by many more. The government has also banned thermocol in 2021.
Yeah,
So
good.
and it is on a rapid rise
So
in its
that's a
consumption.
good business for you, isn't it? That part of it.
It's an excellent business for us. It took us a really long time. We thought people will jump on us and give us a big hug and say, "Wow, wonderful! Here we are." But they said, "Cut my cost and I'll take it." So it took us a really long time, and then we met Adi Godrej himself, and
Okay.
then he had to push it, and then he pushed it. It took about 1 year and nothing happened, and then in one of the board meetings again he said, hey, wo honeycomb ka kya ho gaya, wo kuch hua kya? That
Mm.
sort of thing. Then people are like, oh shit, he really remembers, and then really sort of came up again, and then eventually we dropped their cost, and they saved close to 2.5 crores per annum by moving towards honeycomb, and that is the only reason they have moved towards it. And then, of course, now in their sustainability reports, we look excellent. But the truth of the subject is that we saved them money.
Okay.
Uh,
That's good. That's good.
Are there
So,
any other products, Praveen, that you're working on similar to this? So one is you've addressed the packaging industry. One is for the building industry. Are there any other products that are uh, in the making?
we are using the same technology and addressing multiple situations. We have now made because of the thermal efficiency of this, we have made solar powered cold storage units.
Okay.
interesting.
These are small format cold storage units just to store about 2.5 tons of material. The issue today that a farmer has, and our farmers are largely in the range of 2.5, 3 acres of land. And today, after they harvest, they do not have any storage, for which this farm gate as an issue is happening, where people come and sort of take it at throwaway prices, and they are eventually not so. So if they have a cold storage unit to store this, it becomes a big deal. The reason it's not put today is because there's no power. So by making these sort of units which are solar powered, you're giving a big advantage to the farmer. Number one. Second is 43% of all the produce that we make goes to waste simply because of lack of storage. So by deploying small format, just 2.5 tons of load, it's just 8 feet by 8 feet by 8 feet, small cold storage units. And because of our air conditioning and refrigeration background, we have used a home air conditioner uh, to be able as a refrigeration system inside of this cold storage unit. A home AC is one of the most efficient refrigeration systems and the most cost effective. The refrigerant gas has a capacity to go down up to 3 degrees centigrade, but they don't allow it in our refrigerators today, in our home ACs today, because it consumes too much power. So just cut it off at 16 degrees. But we have bypassed that system and run it, and we have developed the electronics. So we take a home AC, we pull out the electronics and bypass it to our electronics, plug it into our food storage unit made out of this, and we're now just about in the launch of making this food storage unit. This is also another application where the government has huge amount of incentives available to for cold chains and things like that. And this again brings about huge number of entrepreneurs, multiple places. We share the technology with them. They go, they assemble, you know, same system. But this is another problem that we're addressing through this technology.
That's very interesting.
Right.
If you visit our facility, you will be able to see the unit.
And now
And
now we feel encouraged to come.
Yes.
now it's now
Now we
it's
can
worth the
brave the
trek.
traffic. Yeah.
Yeah,
We'll
now
come.
that's it. Yes.
How big is your research
Yes.
team, Praveen? I mean, how many employees in
So
total? And how many
see,
specifically are there?
this Unified Intelligence is still a very small company. It's just about 1.5 year old. We have about 12 people on the shop floor. We have about three in design, and three of us are founders. We actually the origin of this entire technology is from a foundation called VASPA Foundation. VASPA Foundation focuses on basically engineering solutions to add value to waste. That is the fundamental focus of the institution. And at the output of this, we have the honeycomb technology, we have the plastic technology, and things like that. And we continue to do a lot of work, wherein we are also doing water, because we believe that tomorrow's future homes are going to be purchased not because of the distance it has from MG Road, versus today's 15, 16-year-olds who are buying homes tomorrow are going to ask, where is the water coming from? Where is the electricity coming from? How far is my essential items? That's the That's the language. So what we're also doing in this is that we're inducing condensation inside this panel, in which water trickles down through the walls and actually starts filling a water tank in the base.
Mhm.
So because this material is completely water resistant and it is food grade material. So we're creating condensation where water will flow through the walls, fill a tank. So basically, talking about self-sustaining homes is our ultimate focus. Wherein power, electricity, we're having drip irrigation through the wall, where we can have wall gardens. We are working. We've done some calculations where we're able to give almost a guaranteed output. In your balcony, you will be able to get so many kilos of potato. You will get so many kilos of tomato.
Okay.
Because as long as you're having water, XYZ. I mean, these are all possibilities through the technology and through this construction material. And self-sustaining homes is finally our eventual goal.